Alright, hello, Mr. Beeland here with your science lesson for today. Now we are extending to using heat or thermal energy in everyday life and how that is applied, okay? So there's a few different ways that we use thermal energy in our everyday lives, in particular in our houses. One of those ways is through electric heat systems. So this is when you have electrically heated coils that get put inside the floors or the walls, and then those coils get heated up by electricity, and then through conduction, remember conduction is direct contact with the air heats up, and the houses or the rooms will also heat up. The other way, and this is probably the most common way that houses are heated, is through a forced air system. And so a forced air system is when you have a furnace. And a furnace heats up the air inside and around it. This air then gets blown through the house via fans and gets pushed through all of the air ducts, and then it comes up at all the different registers in one's house. This is probably the most common way that houses get heated. The last way here is through a radiator system, okay? So a radiator system is when you have a closed metal container, and inside that container is either water or steam. This gets heated up, and then it gets transferred to the air, right? The air gets heated up by direct contact, by conduction with the steam or the water. This air is just then naturally travels throughout the house or throughout the room or throughout the space through convection. Remember, convection is when the heat goes up and the cold goes down, and it just starts cycling through all the different areas that it's supposed to go into. Okay, so there is one other system or one other way that we can look at generating heat or thermal energy, and that's through radiation, right? These three here were either conduction or convection. But we can talk about radiation a little bit, and this is basically through solar heating, right? The only realistic way to generate radiation thermal energy in a useful and high enough amount of energy is through the sun. And so we can do this through either positive systems or through active systems. Okay, and a positive system is just letting the rays in, the sunlight in, and letting that just kind of warm up the space, right? So windows would be a positive system for solar energy, right? It just, the windows are there, lets the sun in, warms up the room. An active system is one that uses solar collectors, right? So this is where you'll see the panels, right? So this is just windows letting stuff in. This is panels absorbing solar energy, right? And then using that energy to heat up the areas. All right, so to close this off, I do want to talk about two things when we're talking about these systems and heating up areas, okay? And this is something called thermodynamics. And what is thermodynamics, right? Thermodynamics is the study of the relationship amongst thermal energy, heat, and something called work, right? So how much work has to be put into actually heating something up, right? So this is the study of thermal energy plus heat plus work. So why am I bringing this up? This is important because thermodynamics has two main laws, right? The first one says that the increase in thermal energy equals work done plus heat transferred. So what does this really mean, right? So it means that the way that you increase thermal energy is by adding heat, right? So through radiation or convection or conduction. And then if you're doing something else that's generating work, so another way of converting energy. And we're going to look a lot into converting energy in the next unit. But for now, all this means is that you have to do something like heat up an electrical coil, and that will generate the heat to transfer around, right? The second rule is thermal energy will not go from cold to hot without work. Okay, so again we're using this word work, right? So thermal energy will not go from a cold object to a hot object. You will not be able to pull the energy out or the heat out of a cold object and put it into a warm object, because just like everything else we've been talking about, things like to be balanced, right? Things like to go from, like similar to osmosis, right? You have a high amount of water and a low amount of water. It wants to be balanced. Same with your electrons, right? You have a lot of electrons over here. You have only a few electrons here. They want to be balanced. No surprise. Hot and cold wants to be balanced too. Things will naturally give up that heat to the colder environment. The only way to generate that cold is through work. And this is an important rule, for example, with air conditioners, right? You can't just make cold air in your room if it's hot unless you plug in your air conditioner, right? It will not naturally get colder inside. Okay, so this is a little bit of theory, right? So we're just talking about some applications inside our own houses, and then we're just talking about two of these rules. And these are gonna, again, come up in our physics unit. This is kind of like a little cross section or intersection between the two units here. So your task for today is going to actually be to do some research on your own house and figure out what type of system does your house use to heat itself up. Ask your parents to help you. If you don't know where your furnace is, or if you have a radiator, ask where the radiator is, or if you have electric floors, ask where the coils are all set up, right? Have a little bit of a look at what the pathways for your vent ducts are, right? Try to draw a diagram that illustrates how the thermal energy moves inside your house. And that's kind of the activity for today. Okay, that is it. This is the end of our chemistry unit. I will be putting up a review